Just after midnight in early August, the mountain known as the Volcano of Fire tore itself open again, and this time the ground shook hard enough that people in villages more than 20 miles away heard the explosion before they ever saw the sky turn red. Within hours, Guatemala's disaster agency had declared its second highest emergency alert level nationwide. 3 villages had been placed under the highest possible danger rating, and rivers of superheated ash and rock were already racing down 6 separate ravines carved into the mountain's flanks at speeds that would outrun a car on a highway. This is Fuego, one of the most relentlessly active volcanoes on the entire planet. And what happened here over the past several days is not a routine eruption that made the news cycle for a day and disappeared. Scientists monitoring the volcano in real time watched it escalate through distinct phases in a matter of hours, phases that eventually pushed it into what volcanologists call a paroxysmal state. The most violent classification, an eruption like this can reach short of a full-scale catastrophic collapse of the summit itself. By the end of this video, you will understand exactly what has been happening beneath this mountain, why the danger here is fundamentally different from the lava flow eruptions people picture when they think of volcanoes, and why the response to this eruption, compared to the deadly one that struck the same mountain 8 years ago, tells us something genuinely important about what has changed and what still has not. If you have ever wondered how a volcano can kill people without a single drop of lava ever reaching them, this is the story that explains it in full. Drop a comment and let me know if you have ever lived near an active volcano or felt an eruption firsthand, because the psychology of watching a mountain like this from the ground is unlike almost anything else on Earth. And if you want to stay updated as the situation continues developing, go ahead and subscribe now, because Fuego does not stay quiet for long. Let's establish exactly where this volcano sits and why it behaves the way it does, because the geography here explains almost everything about the danger. Fuego rises to roughly 3,163 meters, about 12,246 feet, situated just over 20 miles southwest of Guatemala City, close enough that the country's capital and its more than 2 million residents sit well within range of significant ashfall whenever the volcano has a major episode. It forms part of the Central American Volcanic Arc, a chain of volcanoes stretching across the isthmus that exists because the Cocos Oceanic Plate is being forced slowly and continuously beneath the Caribbean plate in a process called subduction. As that descending slab of oceanic crust sinks deeper into the earth, it heats up, releases water trapped in its minerals, and that water lowers the melting point of the surrounding mantle rock enough to generate the magma that eventually rises and feeds volcanoes exactly like Fuego. This is the same basic mechanism responsible for many of the world's most explosive volcanoes, distinct from the gentler, effusive volcanoes you see constantly compared to it, like the ones in Hawaii, which sit over an entirely different kind of geological feature called a hotspot rather than a subduction zone. Subduction zone volcanoes tend to produce thicker, gas-rich magma that does not flow smoothly. It builds pressure instead, and when that pressure finally releases, it tends to do so violently rather than gently, which is exactly the pattern Fuego has repeated over and over across recorded history. Fuego is not a volcano that erupts once every few centuries and then goes back to sleep. It has been erupting in some form almost continuously since 2002, and historical records document eruptions at this same mountain stretching all the way back to 1531. Between those large historical episodes, it maintains a kind of near-constant low-level activity, regular small explosions, steady degassing, and modest ash emissions that longtime residents of the surrounding towns have essentially learned to live alongside as part of daily life. That familiarity is itself part of the danger, because it can make a genuinely dangerous escalation feel, in its early hours, like just another ordinary day at a volcano that never really stops rumbling. Now let's walk through exactly what happened this time, because the sequence of events matters for understanding both the danger and the response. According to Guatemala's Disaster Coordination Agency and its National Seismology Institute, activity at Fuego began ramping up in late July, with a clear escalation beginning around August the 2nd. By the early hours of August 4th, the volcano had crossed into what officials described as a critical explosive phase, sending ash plumes rising roughly 6 kilometers, close to 4 miles into the atmosphere, accompanied by visible lava flows spilling down its slopes and clouds overhead, glowing red from the heat below. Guatemala's Institute of Volcanology issued a direct warning that the mountain was moving toward an even more explosive phase, and within hours, that warning proved accurate. The country's disaster agency declared a nationwide orange alert, one step below the highest possible red designation, and evacuations began in the villages closest to the summit, including communities in the Escuintla, Zacatepeques, and Chimaltenango departments that ring the volcano's base. By the time the eruption reached its most intense point, Pyroclastic flows, the fast-moving avalanches of superheated gas, ash, and rock fragments that represent the single deadliest hazard this volcano produces, were racing down 6 separate ravines simultaneously, channels locally known as barrancas, that funnel material away from the summit in the same path as eruption after eruption. It is worth pausing here to properly explain what a pyroclastic flow actually is, because the word gets used casually, but the physical reality behind it is almost impossible to overstate. The United States Geological Survey describes these flows as a chaotic mixture of hot volcanic blocks, pumice, ash, and gas that destroys nearly everything directly in its path. They are not slow-moving rivers of molten rock that a person could reasonably outrun on foot, the image most people carry around from movies and documentaries about lava. They behave more like an avalanche crossed with a sandstorm crossed with a blast furnace, and individual rock fragments suspended within the flow can travel at speeds up to 50 miles an hour, while the leading edge of the largest flows on record have been documented moving at speeds exceeding 400 miles an hour, with internal temperatures that can climb past 1,000 degrees Celsius, hot enough to instantly ignite anything organic in its path. According to research compiled by the United Nations Office for Disaster Risk Reduction, pyroclastic flows were responsible for nearly 60,000 deaths across roughly 100 documented incidents between the years 1500 and 2017, making them the single deadliest category of volcanic hazard in recorded history, more lethal than lava flows, ashfall, or volcanic gas combined. These flows typically travel as 2 layers moving together, a dense, ground-hugging current that follows the exact contours of ravines and valleys the way water would, and a lighter, more diffuse ash cloud riding above it that can detach and surge over obstacles the denser current would otherwise be channeled around. That 2-layer structure is precisely why Guatemalan officials issue warnings naming specific ravines by name rather than simply declaring a generalized danger zone around the volcano, because the actual path any given flow takes depends heavily on the terrain it is funneled through. Pyroclastic flows are dangerous enough entirely on their own, but Fuego produces a second, closely related hazard that has arguably done more cumulative damage to surrounding communities over the years, something called a lahar. A lahar is essentially a volcanic mud flow formed when the loose ash, pumice, and rock debris deposited by pyroclastic flows and ashfall mixes with water, whether from heavy rainfall, melting snow, or a nearby river channel. Depending on the ratio of water to solid debris, a lahar can behave anywhere from a fast-moving flood of muddy water to something with the density and destructive force of wet concrete surging downhill. Guatemala sits in a tropical climate zone where intense rainfall is common, which means the loose volcanic material deposited during an eruption often does not sit still for long before a storm mobilizes it into a lahar capable of traveling for miles down the same ravines the original pyroclastic flows carved out. During this most recent eruption, authorities specifically warned that mud flows extending as long as 7 kilometers, well over 4 miles, were already descending from the volcano even as the explosive activity itself began to ease, with incoming rain expected to increase the risk of additional flows in the days that followed. This is exactly why volcanic danger at Fuego does not end the moment the visible explosions stop. The material an eruption leaves behind on the mountain's slopes remains a serious hazard for weeks or even months afterward, waiting for the next heavy rainstorm to remobilize it. To understand why this particular eruption carries so much weight in the public consciousness of Guatemala, you have to go back to June of 2018, because that event remains the reference point against which every subsequent eruption at this mountain gets measured. On June 3rd of that year, Fuego produced what remains the deadliest eruption in its recent recorded history, a sub-Plinian event that sent an estimated 20 million cubic meters of airfall ash into the atmosphere and generated roughly 50 million cubic meters of pyroclastic flow deposits across the volcano's flanks. Explosions came at a rate of 8 to 10 per hour at the height of the activity, and pyroclastic flows descended through the Las Lajas and El Jute ravines in particular, ultimately overwhelming and burying the communities of San Miguel Los Lotes and El Rodeo under thick layers of scalding ash and debris. The official death toll from that event stands at 215 confirmed fatalities, alongside a similar number who were left missing and presumed dead, many of them never recovered from beneath meters of hardened volcanic material. In the investigation that followed, volcanologists identified specific gaps in the monitoring and warning systems available at the time. Officials had only a single seismometer installed on the entire volcano, and the region's early warning infrastructure for both pyroclastic flows and lahars was widely described afterward as underdeveloped relative to the actual level of risk the mountain posed to the communities living in its shadow. That history is exactly why the response to this year's eruption deserves genuine attention, because it represents a measurable test of whether the lessons from 2018 actually changed anything on the ground. As pyroclastic flows moved through 6 separate ravines this time, including the same Las Lajas channel that helped bury San Miguel Los Lotes 8 years earlier, and as a major highway crossing, that same drainage was shut down as a precaution, authorities reported that as of the evening of August 4th, no casualties had been confirmed, a fact officials directly attributed to faster, better coordinated evacuations that had been rebuilt and rehearsed in the years since the 2018 disaster. Roughly 1,000 people were moved out of the highest risk communities during the most intense phase of activity, and that number grew as the eruption continued, with reports indicating around 1,700 people remained in shelters as the situation stabilized. Guatemala's disaster agency described the following 72 hours after the peak of activity as critical, continuing evacuation orders for 3 villages placed under the highest red alert level, even as the explosive activity itself began to visibly decrease. A spokesperson for the agency delivered a message that has become something of a standard refrain in Guatemalan disaster response in the years since 2018, urging residents that if an evacuation is ordered, or if conditions genuinely threaten their lives, they should follow the principle of self-evacuation rather than waiting for door-to-door instructions that might not arrive in time. By the following week, the country's Seismology and Volcanology Institute reported that the most intense phase of the eruption had ended roughly 50 hours after it began, with camera footage no longer showing active lava spurting from the crater, or the ground pulsations that typically accompany the most violent explosive activity. But officials were careful to note that reduced intensity does not mean the danger has fully passed. Accumulated material sitting at the summit and along the upper slopes continues to be unstable, capable of collapsing on its own and generating fresh pyroclastic flows even without a new explosive eruption driving them, which is why the Volcanic Ash Advisory Center in Washington continued issuing updated bulletins on ash movement in the days that followed, and why the villages nearest the summit remained off limits even after the most dramatic footage had already stopped circulating online. It is worth being precise about the actual mechanism driving an eruption like this, because understanding what is physically happening underground makes the entire event far less mysterious and far more explainable. Deep beneath Fuego, magma-rich and dissolved gases, primarily water vapor and sulfur dioxide, sits under enormous pressure within a chamber connected to the surface through the volcano's central conduit. As that magma rises toward the surface, the pressure surrounding it decreases, and just like opening a shaken soda bottle, the dissolved gas begins rapidly expanding out of solution. In a volcano producing thin, fluid, gas-poor magma, that expanding gas can escape relatively smoothly, producing the kind of gentle, flowing eruptions people picture from Hawaiian volcanoes. But Fuego's magma is considerably thicker and more viscous, which traps the expanding gas rather than letting it escape freely. Pressure keeps building within the confined magma until it overcomes the resistance holding it back, and the entire mixture erupts violently, fragmenting the magma itself into the ash, pumice, and rock fragments that make up both the eruption column rising into the sky and the pyroclastic flows collapsing back down the volcano's flanks. When that eruption column becomes too heavy and gas-poor to keep rising, or when a portion of it simply cannot sustain the vertical thrust needed to stay airborne, it collapses under its own weight and comes crashing back down the mountainside as exactly the kind of ground-hugging pyroclastic flow that swept through those 6 ravines this week. This collapse mechanism, rather than a directed lateral blast, is the dominant hazard at Fuego, and it is one of the reasons scientists monitoring the volcano pay such close attention to the height and behavior of the eruption column itself, because a column that suddenly loses its ability to sustain altitude is often the clearest visible signal that a dangerous flow is about to begin. Monitoring a volcano like this involves considerably more than watching for smoke and listening for explosions. INSIVUMESH, Guatemala's National Institute for Seismology, Volcanology, Meteorology, and Hydrology, maintains a network of seismometers around Fuego's base, specifically to track the small earthquakes generated as magma forces its way through cracks in the surrounding rock on its journey toward the surface, a process that typically intensifies in the hours and days before a major explosive episode. The Institute also tracks changes in gas emissions, since a rising magma body characteristically releases increasing quantities of sulfur dioxide as it approaches the surface, and monitors subtle deformation of the ground itself, since a swelling magma chamber physically pushes the surrounding rock outward in ways that can be measured using satellite radar and ground-based instruments, the exact same techniques used to detect the fault creep discussed in earthquake monitoring elsewhere in the world. Video and thermal camera networks positioned around the summit provide continuous visual confirmation of activity, allowing scientists to watch eruption columns rise and, critically, watch for the specific moment a column begins to collapse, since that collapse is often the first visible sign that a pyroclastic flow has actually begun, rather than something that can only be confirmed after the fact. None of this monitoring makes Fuego predictable in any precise sense. Volcanologists have been direct about the limits of what current science can actually forecast, and this is an important distinction to draw clearly rather than overstate. Scientists can identify that a volcano is entering a period of elevated risk, They can track escalating precursor signals like increased seismicity and rising gas output, and they can issue increasingly urgent warnings as those signals intensify, exactly as Incivumate did in the days leading up to this month's paroxysmal phase. What they generally cannot do is name the specific hour an eruption will cross from elevated activity into a genuinely catastrophic pyroclastic flow generating event, which is precisely why the emphasis in disaster response has shifted so heavily toward faster evacuation protocols and public education about self-evacuation, rather than relying entirely on scientists to provide a precise countdown before every dangerous episode. This is also a useful moment to address something that tends to circulate whenever any major volcano makes international headlines, because the instinct to connect unrelated events is strong, and it deserves a direct, honest answer rather than being ignored. Fuego's escalation this month is not connected to any broader global surge in volcanic activity, and it is not evidence of some planet-wide geological awakening tying together every volcano currently active anywhere on Earth. Guatemala sits along the Pacific Ring of Fire, the same horseshoe-shaped arc of tectonic boundaries responsible for roughly 75% of the world's active volcanoes and the overwhelming majority of its earthquakes. And volcanoes along this arc, including Guatemala's own Pacaya and Santiaguito, do periodically show correlated increases in activity, simply because they sit along interconnected sections of the same regional tectonic system. But Fuego specifically has been in a state of near-continuous activity for over 2 decades, with major explosive episodes occurring with enough regularity that volcanologists studying it treat events like this one as an expected, if serious, part of its normal behavior rather than a sudden and inexplicable departure from a previously calm baseline. This is not a supervolcano stirring toward some civilization-ending event, and it is not magma from unrelated volcanoes secretly synchronizing across a continent. It is one of the most reliably active volcanoes on the planet, doing, in a more intense form than usual, almost exactly what it has done repeatedly across 5 centuries of recorded history. And what makes each individual episode dangerous is not some unprecedented new mechanism, but the simple, tragic fact that hundreds of thousands of people live directly within reach of its ravines. What has genuinely changed, and what deserves real credit, is the response infrastructure built in the years since the 2018 tragedy. Guatemala's Disaster Coordination Agency has worked to rebuild and rehearse evacuation procedures, specifically around the lessons learned from a disaster where a lack of advance warning and insufficient monitoring contributed directly to a death toll that could plausibly have been far lower with faster, more coordinated action. The difference this time is not that the eruption was necessarily smaller or less violent, since pyroclastic flows moved through 6 ravines simultaneously during a confirmed paroxysmal phase, the volcano's most intense classification of explosive activity. The difference is that roughly 1,000 people were moved out of harm's way before those flows arrived rather than after. And as of the most recent reporting, that faster response has meant 0 confirmed casualties from an eruption that, under 2018-era monitoring and evacuation timelines, could very plausibly have produced a far more serious outcome. That contrast matters enormously, and it echoes a pattern that shows up again and again in disaster science more broadly. The idea that the raw power of a natural hazard and the human cost it ultimately produces are 2 genuinely separate variables, with the gap between them determined almost entirely by how seriously a society invests in monitoring, warning systems, and rehearsed evacuation procedures well before the crisis actually begins. It is also worth being honest about what remains unresolved and what residents around the volcano are still actively contending with, even as the most dramatic footage fades from the news cycle. The 3 villages placed under the highest red alert level remained under evacuation orders even after the explosive activity itself had visibly decreased, because the hazard from unstable accumulated material at the summit and the ongoing risk of rain-triggered lahars does not disappear the moment the lava stops flowing and the ash plumes stop climbing into the sky. Communities were advised to cover open water sources to prevent ashfall contamination and to use face masks as basic protection against airborne ash particles, precautions that remain necessary for as long as ash continues drifting from the crater, even during periods officials describe as a general reduction in intensity. Roads connecting some of these communities to the outside world stayed closed. Agricultural land in the surrounding departments faced ongoing ashfall damage to crops and the broader economic disruption from a major highway closure and weeks of tourism impact around nearby Antigua, Guatemala, a colonial city that normally draws large numbers of visitors, specifically because of its dramatic views of this same volcano, continued well beyond the point when the eruption itself stopped generating dramatic headlines. There is a broader historical parallel worth drawing out here, because it helps explain why volcanologists reach for the word pyroclastic with such gravity whenever they describe an eruption like this one. The same basic phenomenon that swept through Fuego's ravines this month is the one that destroyed the Roman city of Pompeii in the year 79, when Mount Vesuvius erupted and sent surges of superheated gas and ash racing down its slopes fast enough to kill residents where they stood, preserving their final positions under layers of ash for nearly 2,000 years until archaeologists began excavating the site. Volcanologist Janine Krippner, who studies these flows professionally, has described them as genuinely unlike almost anything else that occurs naturally on Earth, closer to a fast-moving sandstorm filled with lethal heat than to any avalanche or landslide most people have direct experience with. That comparison across 2,000 years and two entirely different continents is not an exaggeration for dramatic effect. It reflects the fact that the underlying physics of a collapsing eruption column behave essentially the same way regardless of which specific volcano produces them, whether that volcano sits on the Italian coast or along the Central American Volcanic Arc, which is exactly why modern monitoring agencies like INCIVU-MAH treat any sustained increase in explosive activity at a stratovolcano like Fuego with this level of urgency, rather than waiting to see how a given eruption column happens to behave before issuing warnings. It is also worth understanding how an eruption of this scale reaches beyond the immediate area around the volcano's base, because the consequences do not stop at the edge of the evacuation zones. Ash plumes, climbing 4 to 6 kilometers into the atmosphere, pose a direct hazard to aviation, since volcanic ash can severely damage jet engines, and the Volcanic Ash Advisory Center in Washington, the agency responsible for tracking ash clouds across the Americas, issued repeated bulletins throughout this eruption specifically to help airlines route around the affected airspace. Guatemala's main international airport in the capital continued normal operations through most of the eruption, but officials acknowledged it could face temporary closures depending on ash concentration and prevailing wind direction, a reminder that a volcanic hazard originating in a relatively rural, mountainous region can still ripple outward into the transportation and economic infrastructure of an entire country within hours. Fine ash particles carried by the wind also settle across a much wider radius than the pyroclastic flows themselves, contaminating water supplies, damaging crops, and coating agricultural land in departments well beyond the immediate evacuation zone, and creating respiratory hazards for anyone without adequate protection, which is exactly why officials issued mass guidance to residents in communities that were never at risk from the flows directly but still sat squarely beneath the drifting ash column. It is not that something mysterious or unprecedented has suddenly appeared beneath this mountain. It is that a volcano which has never really gone fully quiet across 5 centuries of documented history just produced one of its periodic violent episodes, driven by the same basic subduction zone magma mechanics that have shaped this entire volcanic arc for millions of years, and that the actual outcome for the people living in its shadow depended far less on the raw geological power involved and far more on how quickly warnings reached them and how seriously those warnings were taken once they arrived. The 2018 disaster taught Guatemala, in the most painful way possible, exactly what happens when monitoring infrastructure and evacuation coordination lag behind a volcano's actual behavior. This month's eruption, moving through the same terrain, in some cases through the very same ravines, appears to represent a genuine test of whether those lessons actually took hold, and the preliminary answer, at least in terms of confirmed casualties, has been considerably more encouraging than it was 8 years ago. It also helps to place Fuego within the wider family of Guatemala's volcanoes, because the country's exposure to this kind of hazard is not limited to a single mountain. Guatemala hosts several other historically active volcanoes within relatively close range of Fuego, including Pacaya to the southeast and Santiaguito further west, both of which have shown increased activity during past periods when Fuego itself was erupting heavily, a pattern consistent with the fact that all of these volcanoes are fed by magma generated along the same subducting plate boundary rather than by any direct underground connection between their individual magma chambers. This regional clustering is precisely why Guatemala's Disaster Coordination Agency maintains a nationwide alert framework rather than a hazard plan built around any single mountain, and it is part of why an eruption at Fuego tends to trigger heightened monitoring across the broader volcanic arc, rather than being treated as an isolated, contained event. None of that means the danger is behind anyone living near this mountain permanently. Fuego does not operate on a schedule that gives comfortable, predictable gaps between major episodes, and volcanologists studying it are clear that periods of reduced activity, even ones stretching for weeks or months, do not represent the volcano returning to some kind of permanently dormant state. The magma system feeding it continues recharging beneath the surface. Seismic monitoring continues tracking the small earthquakes generated as that system shifts and pressurizes, and the same 6 ravines that carried this month's pyroclastic flows will very likely carry the next ones whenever the volcano's next significant episode arrives, whether that is weeks, months, or years from now. What residents, disaster planners, and anyone following this story from outside Guatemala can actually take away from it is a genuinely useful, evidence-based understanding of how modern volcanic risk actually gets managed. It is not managed by predicting the exact hour an eruption will turn catastrophic, because that capability does not currently exist for any volcano on Earth. It is managed by tracking the precursor signals closely enough to issue warnings early, by building evacuation systems robust enough to move people out of harm's way quickly once those warnings go out, and by treating every single major episode, however routine it might start to feel after decades of near-continuous activity, with the same seriousness that a tragedy like 2018 demanded in hindsight but did not receive in the moment. If this kind of grounded, evidence-based breakdown of what is actually happening beneath an active volcano is useful to you, subscribing means you will not miss the next update. As monitoring continues and as scientists learn more about exactly how this particular episode compares to the volcano's broader historical pattern. Sharing this with someone who has never really understood the difference between a slow lava flow and a genuinely lethal pyroclastic surge is one of the more useful things you can do with the next 30 seconds, since that distinction is exactly the kind of knowledge that shapes whether someone treats a volcanic warning with the urgency it deserves. Let me know in the comments what surprised you most about how this eruption actually unfolded. Whether it was the sheer speed of those pyroclastic flows, the scale of the response built since 2018, or simply how active this particular mountain has been across the centuries, most people have never heard its name mentioned. Either way, the volcano of fire just proved once again that the ground beneath it was never truly at rest, and the difference between a headline and a tragedy came down, this time, to how quickly the people living in its shadow were able to move.